Welcome back. You're still watching the Morning Express, the weekend edition on Advocate Broadcasting Network, channel 258 on DSTV, 140 on Star Times. We've already given you a hint of what we want to talk about. Our guest is already standing by to make sense of the conversation, especially the concerns arising from this CNG conversion. Our guest is an oil and gas expert. Himself has also worked an oil company in this capacity, and that gives him the knowledge to speak aptly on the matter. Join us as we welcome Dr. Wisdom Enang. Good morning to you, Doc.
Good morning, Ike, and good morning, the
Jennifer. Good morning, Dr. Wisdom. It's good to have you on the program.
Thank you.
Well, there are a number of concerns with regards to the conversion, CNG, and questions as to what is CNG, what is LPG, what is LNG, a number of things. And we just want to understand what's the difference between all of these and which is safer.
Okay, so I'm going to put into context I think what you're asking me is what's the characteristic difference in all of these type of fuels. Now, I think the first way I want to tackle this is to talk about in terms of the chemistry behind it. So first and foremost, the CNG is methane. And methane is a lot lighter. That's your dry gas. And that's the one that the vehicles typically use. What you find is they're all providing energy. But they're providing it with a different energy configuration and with a different safety consideration. I think that's the way I want to put this. If you look at maybe CNG, for example, it is a lot more volatile than the other ones because it's quite light. That's which is one of the lightest on the hydrocarbon scale. The LPG, on the other hand, is butane and propane. They come together to create LPG. But what we use to cook is the butane component. The propane is what they use to fly the aircrafts. So that's the difference there. And I'm telling you in terms of application. The LNG, on the other hand, it's not really a form of gas. It is a form of gas transportation. The reason I say so, the LNG is basically natural gas that has been liquefied for the sake of transportation. And so if you look at the CNG and the LNG, essentially in a room temperature, they're both the same thing, natural gas. That's their chemistry. CH4, carbon, one molecule of carbon and 4 molecules of hydrogen. That's the way it works. So when you look at why do we have the difference between LNG and CNG, simply is different. One, we are pressurizing it so that we can put more into a tank, a holding tank, and we can take it from point A to B. But because it's compressed, there's a lot of pressure there. There's also an additional pressure when it comes to the ambience, both the heat and the sort of cyclic load as you go along the road. CNG is used for short transportation. You don't use it for long transportation. LNG, on the other hand, is still natural gas, which has been liquefied in this case. So if you cool gas, at very extreme, what we call cryogenic temperatures, below zero, they tend to liquefy at some stage. And they even give you a better storage than the compression. Because as you compress gas, you will tend to have heat at some point. So that's why the liquefied one is better.
Okay.
It allows you to store more and then take it for longer distances.
Good. Now, Doc, you got me there. There's an aspect of this conversation which is very essential as far as I'm concerned. We're being told that we should convert our vehicles, to CNG and, of course, reduce the dependence on fuel. But you mentioned in your analysis that the CNG can't do long distance. Isn't that a problem in itself?
Well, it cannot do long distance because I'm talking about you going from, say, Nigeria to London with a CNG. You couldn't do that. You couldn't put it into CNG, say, tankers and take it abroad. but you can still take it within Nigeria. It's not a long distance. In context, yes.
Okay.
But if you're thinking about taking abroad, yes, that's a very long distance. You can't do that.
Okay, but there's also the concern. Now, the presidential initiative, compressed gas initiative, had set up to reduce petrol importation by 5.5 million litre, with a plan to convert about 1 million vehicles in a year. Do you think Nigeria has the capacity to meet this target? He says to convert 1 million vehicles within a year.
Infrastructure-wise.
Infrastructure-wise, do we have the capacity to meet this target?
Currently, we do not have that capacity, but what I think should happen is, we should partner with the subnationals. By that I mean the state government, and the partnership with the state government, between the federal and the state government, should then empower the state government to bring in people that would build on the basis of build, operate, and transfer, that would build the daughter stations.
Okay.
When they have set up, so for example, in Akwa Ibom, we could do a pilot case, build one in Uyo, build one in Eket, and we could get a supplier that would take compressed natural gas, take it to the daughter station and compress. And people will say, what is different between a daughter station and what's different between a mother station, if that's the word. The thing is this: a mother station would take a feed from a CNG pipeline, compress it, produce the gas at the level of quality required, quality in terms of level of dryness of the gas, level of impurity that's required, and at the right pressure. It produces the gas. However, you would need to have access to a CNG pipeline, which is back to the infrastructure problem that you have talked about. And you need to have one very close to you. Now, if you do not have one close to you, what you do is you set up a daughter station. A daughter station is like a normal petrol station, only that it uses compressors. It doesn't produce the fuel there, so it doesn't refine the fuel, just like in the petrol station. But there is a holding tank, a really huge buffer tank. That buffer, you can take CNG from anywhere in the country and store it in there, and the daughter station only dispenses it out to the people that are buying fuel, to the customers. The reason I have proposed this model is because between 12 to 18 months, you can actually set up a daughter station. And I say this with the benefit of hindsight, having spoken to some original equipment manufacturers at the just concluded Gas Investment Forum, which is where the presidential initiative on CNG came to talk about some of these innovations. So when I spoke to them, yes, they can do it. So meaning that technically in 18 months, Akwa Ibom could get a daughter station with a big tank, get a supply deal, and people come and whoever supplies CNG around the world, we have different suppliers. I mean, NIPCO is one of them, and the rest. You can just get them to fill that tank up every month, maybe, and then people can come around and get it dispensed into their vehicle. So in 18 months, we could get the infrastructure, or attempt to get the infrastructure set up for that dispensing. But the worry is also the financing of the conversion. That's another big problem. Because ultimately, you have to understand that no technology, unconventional technology, energy technology is affordable at the initial stage. What happens is that the running cost is cheaper, but the front cost, which is the capital investment, is quite expensive. That's the truth of the matter.
Now, Doc, if I may come in, one of the concerns raised by people is the issue that this CNG conversion limits transportation only to vehicles. People who do tricycles, motorcycles, and some others. Will we see this other interest considered, including trucks as well?
Okay, right. So the biggest problem with CNG isn't the fact that it could not be adapted to all technologies. No, it's not that, or all automobile technologies. It is the fact that you need to have quite a large and heavy tank. And the reason I say large and heavy tank, you could technically use a carbon fiber. Sorry, you could use an aluminum tank for petrol. You could also use a carbon fiber, but that's quite expensive. You could use aluminum tank for petrol. Even you could use, I mean, we've seen plastics. People use plastics to hold petrol. But when it comes to CNG, it's got to be steel. And that steel has to be sized to manage the maximum allowable working pressure of that particular steel tank. And it's really heavy. So that's why it's typically in the vehicles, because the vehicles are then sized to carry that sort of weight, and it could be conspicuously, it could be unconspicuously hidden at the boots. Think about it. You can apply it to tricycles. You can apply it to everything. But the issue is you would need to reconfigure the entire tricycle itself. And I'll give you context. Remember, the goal here, when we talk about a just energy transition, it's an energy transition that takes into cognizance Nigeria's realities and economy. What is Nigeria's realities? We still need PMS, because tomorrow the reliability of supply may not be there for CNG. At least we know that for certain, because we're still struggling. So what that means is you will need to have a dual vehicle, not just a CNG. So I mean, the easiest thing is convert your bike, change that tank, make it stronger, and let it be only CNG. But the truth of the matter is, I wouldn't do that, because what if you run out of the CNG? You need to dualize it, keep the PMS there, but have a CNG. If you do that, technically you can do that, but aesthetically, you will look a bit funny to have a very big tank behind you, which is for the CNG tank, which is why it's only 2 automobiles at the moment.
But if I get you clear, Doc, you're saying for affordability and should we say longevity there, because you made a very important point. We shouldn't do outright conversion. We should still have the vehicle be slightly CNG, slightly fossil fuel.
Correct. And it's not just me saying, that is exactly what India or other countries that are within the neighborhood of where we are and that started this journey 20 odd years ago did. Nobody does a full conversion because it's risky. If the reliability of supply gets into question, you are grounded. So a lot of people opt for the dual fuel option so that they can still retain that. Essentially, they have a wider range of options available to them from a fueling perspective.
Okay, Doctor, let's also consider the safety. Now, for vehicles, they'll be carrying this tank across the locations they are driving to. How safe is this, considering the fact that we've had some explosions in some places, and people are saying it's because of the CNG in the vehicle? Is there an explanation for this, or maybe it was a mistake from someone?
Okay, so I'll give you, I'll just give you some, objective data, and then I'll answer the question. So CNG tank fueling cylinders are quite stronger than gasoline, like I made mention of, and they're meant to undergo severe tests, which such as heat, pressure, and extreme fires. And what they're also fitted with valves. That means that if there's any overpressure scenario, you would be able to have, it would just let off that safety device will relieve and get out of overpressure, and then of course eliminate the risk of explosion from an overpressure scenario. I've just laid out, like I say it from an authority standpoint because I was a piping and vessel design engineer when I worked for ExxonMobil. Now, I'm going to lay out something to you. From that scenario, what that means is that the mode of failure would have been one, having an undersized cylinder for an explosion. It would have been one, an undersized cylinder, a cylinder that is not sized properly. So either they're using fake materials, or they haven't done it properly, or there's some sort of issue impacting the quality of that cylinder in terms of holding that pressure. That's one. Number two is that the safety relief device failed to work. Ultimately, if you overpressure your cylinder, before you kit it up, there should be a valve, a relief valve. Once that pressure is above the set point of the relief valve, it should allow pressure to relieve so that you don't have an explosion scenario. So the explosion scenario that you've said is credible, but it takes us back. And I know the situation you referenced, I think, is somewhere in Edo State. And the investigation found that they actually used a fake cylinder. It was a locally manufactured cylinder, no test whatsoever. There was no sort of certification, and that was what happened. Now, just to, calm the curiosity of your listeners, I'd like to say that the high pressure that we tend to talk about in CNG makes it possible that if there's a leak, the gas tends to escape way faster. And so it has less of a tendency to puddle around like PMS vapor and create a fire hazard. That's the first thing you need to know. Furthermore, I'd like to tell you that when it comes to combustion, there's something we call fuel to air mix ratio. That is, think about the triangle of fire. We need a heat source, we need a fuel, and we need oxygen from air, right? So think about it. For CNG to combust, it has a very narrow range. That means you have 5 to 15% of range for flammability. That means between 5% of CNG and 95% of air, and 15% of CNG and 85% of air is when you can have combustion. If the CNG is so much in a room and outweighs that number, there's no combustion whatsoever. Even if you light it, try an experiment, it will not light. It's something that I've done. Now, CNG also has a higher auto ignition temperature. It means that if you put a PMS right here and open the vapor up, it is more likely to ignite by you just making a phone call close to it. It's more likely to ignite because of the heat of the sun. You put CNG is way, way higher. The auto ignition temperature is way, way higher than even diesel. That is apparently oil, gasoline oil. It's much higher than that. Now, that improves the safety. So when you think about the high ignition temperature, the limited flammability range, you find out that accidental ignition of CNG and the combustion of same is actually very, very less. What you seem to hear like is explosion. But explosion is because someone has patronized a fake cylinder, or basically has not recertified. Now let me drive a point home. When last did any of the of us, right, deliberately take our cylinders and ask for where we can check that cylinder is right? Are you aware that your cylinder over time may not exhibit corrosion on the inside, but there may be corrosion on the outside, there may be corrosion on the inside that further erodes its ability to hold the maximum allowable working pressure? Are you aware that the ASME, American Society of Mechanical Engineers code for designing, it says you need to recertify every 2 years. When last did any of us take our LPG cylinders and go somewhere and say, is this thing does it still have does it still stand the test of time in terms of quality and able to work safely? We don't do that. So this is some of the problems that we face.
Okay, another issue which is of concern now is with the conversion, which means that some vehicles will now be operating based on the CNG. And it takes us to ask, when the car is faulty, we have mechanics who work on cars and they are used to training with the petrol controlled vehicles,
engines, or even diesel engines.
Yeah, but then there hasn't been so much of the CNG except in Edo State, where they've had, I get to understand that they've been using CNG for some years now. But the situation in other parts of the country is quite different. Do you think we're really ready for this CNG?
All right, so let me give you a little bit of how a vehicle works. Now, when you have the various strokes in a vehicle, and and I'm talking about the spark ignition engines, because there are two broad types. There's a spark ignition engines that deals with the PMS fuel, and then there's this compression ignition engines that deals with the with diesel. So I think I want to tell you how it works. Now, the basic operation of a spark ignition engine takes you through the intake, the compression, the combustion, and the exhaust. Now, I'm saying this so that I can tell you how it works. Now, during the intake stroke, the air fuel mixture is drawn into the engine cylinders, and then in the compression stroke, that mixture is then compressed. and then it raises the temperature and the pressure. And in the combustion stroke, a spark plug ignites the fuel mix, and then causing rapid combustion, generates heat, moves the piston forward, and that's exactly what moves your vehicle forward. Now, the reason I had to reel out all of this is this. Essentially, your fuel, that the PMS that you bring in, what happens in the vehicle is this. Once you bring that fuel in, at the combustion point, that fuel has been changed to vapor. That vapor then mixes with air, and then the ignition plug then fires it up and then creates the spark. That is the spark ignition, and that's what drives your vehicle. So essentially, what the engine control unit tends to do when it sees a CNG fuel is, how can we create the vapor air mix that your PMS liquid, what happens is, it is vaporized. So imagine thinking about CNG. CNG is already vapor, so the engine doesn't do that. It just sends the CNG right into where we have the combustion chamber and gets it mixed with air, and then there's a spark ignition. So essentially, what I'm trying to tell you is the spark ignition engine can drive both the PMS and the CNG, exactly, because ultimately what burns is not the liquid, it is vaporized, and that vapor is now what combusts.
Dr. Wisdom, before we let you go, I have one question for you, which for me is very essential to this conversation. The issue of performance. For V8 engines, V12 engines, and the likes that require high performance, we know what fossil fuel does for them in giving them the necessary spark and push. Do we get that with CNG in terms of performance?
No, we don't. You cannot get rapid acceleration with CNG. It's not possible.
Why?
What I mean rapid, well, the reason is because the CNG fuel, first and foremost, doesn't have a high energy content compared to the PMS. And again, there has to be a trade-off. Because think about it. The CNG fuel burns more cleanly, so it has less of the liquid hydrocarbon inside. That's why when you combust it, it tends to give you a cleaner burning. But because it has much the drier hydrocarbon, not the liquid one, they have less energy as well. So that's the truth of the matter. But I'm going to split the performance now. I'm going to talk about getting from 0 to 120, for example, in about 5 seconds. No, you cannot do that with CNG. It won't give you the response, but you can get there in about 9 seconds. When I say 120, I'm talking about kilometers per hour. You can get there in 9 seconds. It will give you that. You can still make your top speed, right? But if you're thinking about that rapid sort of response, it won't give you. It just doesn't have the energy content compared to the PMS and the diesel. Now, the only other thing is this, and this is why I keep advocating that we do a dual conversion, not just solely a CNG. If you need that, once you get to that, you put your throttle, the throttle opens up with that power demand, the engine would sense that CNG is not giving you enough and will slide in the PMS component and make sure that you get that power. So ultimately, if you look at the share between your CNG and your PMS at that point, that sort of request, the PMS will be giving you the power. So that's why it's a very good advantage to balance both type of fuels in your dual conversion.
All right, Dr. Wisdom Enang, we must thank you so much at this juncture. It's an ongoing conversation, and I can tell you one thing, Nigerians are very interested in this conversation, and we'll also keep talking with you. Thank you again for your time, Dr. Wisdom Enang.
Thank you so much for sharing your thoughts with us.
Thank you. Deeply appreciate it. Enjoy your weekend.
All right, you too.
Now let's bring the conversation back home. We have Dr. Juf Owaunze here with us, and he'll share his thoughts with that. However, the biggest conversation throughout the week has been this issue of cabinet reshuffle. We spoke briefly on it on the newspapers, and Dr. Juf, who's a political scientist, is going to elaborate that conversation. Good morning to you.
Thank you. Good morning.
It's great to have you in.
Thank you very much.
Welcome, sir.
I know that you use a fuel engine car.
Sure.
And you've been here when we're talking about this CNG conversion initiative.
Exactly.
What's your thought about it? Do you have any concern?
In fact, the doc has really giving us very good insight on what we should do and what has not been done. Just a few days ago, I was listening to the Labour chairman. He told us that the federal government gave them 10 buses for CNG. And those buses were parked somewhere. With what I have heard this morning, I am wondering when those buses will be on the road. Because the needed infrastructure that we need to put in place, I think not anything has not been done already, because we can't afford to make use of quacks. Otherwise, life will be lost. And if you look at it, the daughter station we are talking about must be domesticated everywhere in Nigeria. And one is not enough for you if we are to move forward. One is not enough for Kate if we are to move forward.
Not even in Kotekpene.
Multiply it through everywhere in Nigeria, 36 states of Nigeria plus Abuja. You will know that we have not started. So with what he has said, and I am sure now that Labour Party and Labour Organization, NLC, and the federal government knows the right thing to do. And it's not a matter of telling us that the next 1-2 months there will be CNG buses on the road. It will not be possible. Let them put her together and agree on how to fund this project. It will be a long-lasting project, not because of the increase in fuel price or because of the wage or whatever, but for the good of Nigerians. Let proper things be done. Let the state government buy into the project and see how it can be domesticated. And I know there are many Nigerians that are ready to be trained to put those things in order. Another issue he mentioned that is very, very important is the issue of gas we use in cooking. Those cylinders, some have used their cylinder for 30 years.
Yeah.
In fact, I have a cylinder.
I don't think I remember the last time I checked mine.
I have a cylinder at my home that I started using in 1996.
And you're still using it?
It was 2 years ago and I have to drop it. And the truth is that when you look at it, the quality and the weight seems to be better than what you have in the market today. But because of this issue of expiration, and so I have to drop it and pick another one. But your man is saying after 1-2 years, you have to go and check. Okay. The problem is that, do we have checkpoint in you? Where do we go to check? To know the quality of the cylinder. Do we have a point to go and do that check? That is another problem. I don't know anywhere.
It's a big one though, but